my name is Kyla Alexander. I teach 5th and 6th grade and have been here for, this is my 6th year, my 10th year overall teaching. Started in kindergarten and moved quickly up to 5th grade where I found my happy place. But here at Echo, I'm also helping work with the teachers as well as with the kids. So I get to see a little bit of everything in terms of the grade levels. K2 is this fantastic foundation. Teaching kindergarten gave me such an appreciation for how much the little ones soak up and how much we really set the tone for what's coming. And it's amazing how what they're doing in kindergarten directly relates to what they're doing in 5th and 6th grade. Those are really connected, even though they seem really far apart. So a little bit about Singapore math and kind of why we chose this 5 years ago and what that decision was. That really what we're seeing and what we were hoping to see and what we actually are seeing is this strong foundation of number sense with our kids and fluency with numbers, being able to move between different representations of numbers and construct and deconstruct them. So making numbers, breaking them, how they come together, how we can use those, and really building an intuitive sense of numbers, that it's not just having to take out a piece of paper and write it down, or having to have a specific process, right? Or having to have keywords and language. Right? We want them to be able to take a situation and represent it mathematically and be able to work with those numbers in whatever way they come. And I've seen that happening, especially now that I have kids now who have had this from 1st grade, and it's such a difference, and it's really beautiful to see. But you guys you're just starting this. You're in this beginning process of seeing this, and it's different. It looks different. It's not different. It's math. It's math, period. But it looks different and it sounds different than what it sounded like to us, right? This is not how I learned math. And I wish I had, honestly. I think that I would have had a different relationship growing up to math than I did. But that's neither here nor there. But it's exciting that these kids are getting a really different experience. And the focus in any new content is looking at how can we actually manipulate and work with this. We start in the really concrete. We start with discs, we start with dice, we start with beans, we start with cubes. Anything that we can touch is where we start, right? That's the concrete. And then we move to pictures, things that we're used to seeing, things that we can draw, we're having the kids draw. And then we move into the abstract, things that are a little bit less, they're not as accessible, right? But we have to make that progression, and that is the progression, right? Because kids can, once they've had that hands-on experience, then they can translate that. And that's what happens. And so there is this really lovely progression of new content, right? Start in the concrete, we move to pictures, and then we move into the abstract. And that's going to happen from K all the way up to 6. And so we've got kids playing and touching and using, so that way they build that sense of it. And that continues throughout the grades. And it becomes a part of their experience, right? That they can then draw on later when they're sitting with 4 plus 3, they have that picture in their head of the 4 blue cubes and the 3 red cubes and how those came together to make 7 cubes. But they need and they get both of those experiences so that when they get up to 5th grade and we're doing 3/5 plus 4/5, it's the same exact thing. It's the 3 cubes and the 4 cubes, and they're all the same. But I wanted to take a look at, within each of the grade levels represented here, what are the things you may see? What are the things that may feel a little bit different to you, but really aren't? And then put you to work a little bit. I think it's really important for you to feel and see what they feel and see. And be open, that's what I ask. So in kindergarten, we're working with addition and subtraction, right? And what we're used to saying is 1 plus 2 equals 3, right? That's addition. Here, and with this, the language is 1 and 2 makes 3. And that is exactly the same as 1 plus 2 is 3, except the language is a little bit different. So if you're at home and you're counting out beans, or you're grabbing t-shirts from the laundry, right? You have 1 t-shirt and you have 2 more, how many does that make? That's the language that the teachers are going to be using. And so if your child is using that language, just know that that's what's happening, right? We use something, it's Chinese counting, right? So 1 through 9 is 1 through 9. And then we hit 10, and it's 110. Okay? 11 then is 110, 1. And 12 is 110, 2. So 13 would be 110, 3, and 14 would be, and 20 is 2 tens, right? And the kids are starting to build that language. And that helps because when they're then coming into addition and subtraction with regrouping, right? And we have to figure out if we don't have enough ones and we need to go to the tens, well, 14, or let's say 24, is the same as 2 tens, 4, so we can take one of those tens, right? But they're getting this language in K to build them for second, right? And it becomes this really lovely progression that seems a little bit strange, I will admit, in the beginning, but it really does all connect. And so if you hear 2, 10, 1, right, that's okay. And if you hear 4, 10, 7, you can say, what number is that? Right. And you can say that to them, and they can say it to you, right? It can be a game, that they can give you that number. How do you, 7, 10, 6, right? They can say that to you, and you can say 76, or you can say it back, right? And it becomes an opportunity to think about it just a little bit different, right, than what we're used to thinking, and really kind of open up that for us as well. Different language, same content. Okay, that is the message, honestly. That is overall what I want to say, that this isn't any different. That it's math, and math is math. It's this really lovely language. And what we're really giving them is an opportunity to play with language and to play with moving between different ways of thinking. Now, I was taught, I don't know about you, but I was taught that certain words mean certain things, right? That more means addition, that less means subtraction, that altogether means adding, right? And those key words I clung to because I felt really uncomfortable having to figure out what I actually needed to do within a problem. And in this particular program, the language piece is that there isn't necessarily one key word, and there isn't and the words that we're used to hearing as one thing may mean something different. And the reason for that is that kids should be able to be put into any situation and be able to figure it out. That they should be able to have enough intuitive understanding of the situation to be able to know what to do. So while those keywords were really helpful for me, in a lot of ways, they kept me in a very small box. And this is saying, no, there isn't just one way to phrase that. And there isn't just one keyword. Okay? So one of the things they hear, I have my notes because I need to take breaths sometimes. But if you heard 3 is 4 less than, 3 is 4 less than, what number? 7, right? But I know for me that less than always was a subtraction, right? So my immediate intuition is to subtract 4 minus 3 and put 1, right? But they're hearing 3 is 4 less than, and they're saying 7, right? So it becomes this opportunity, but then they may say 2 less than 3 is 1, right? Same word, 2 numbers in it. How do I figure out which one is which? And that's where the number sense comes in, right? Same word. And so we really get this opportunity to put kids in lots of different situations where they have to take that extra second to think about it. Which, I don't know, when I was a kid, I was like, okay, well, I heard less, I'm subtracting, that's what I'm doing. And it shut that off from the thinking part of it, and it just became this formula. And yes, there are formulas in math, but there are also so many ways to do one thing. So another one, just for fun, 10 is 1 less than 11, and 6 is 4 more than
13.
Yeah, and 9 is 2 more than. Right. Thank you for participating with me. I appreciate that. So that's K. That's K, right? This is all in K, by the way. We're still in K. And then they move, right? And they're now spending a lot of time making and breaking numbers. And that's where the number bonds come in, right? So so you may see something like this. That's a number bond. Number bond is just basic facts. That's all they are. They're called number bonds because these numbers are connected to each other, right? So within this, the 5, 3, and 2, we have several different equations that are connected to this. Can somebody give me one of them?
2 plus 3 is 5.
Okay, so we have 2 plus 3 is 5. What else do we have? 5 minus 3. 5 minus 2 is 3. What else? 5 minus 3 is 2. And we could do where we switch the addends. 3 plus 2 is 5. And these bonds are the basis for all of their number sense. That the kids are having experiences that help them to create the understanding of those bonds. It's not just, let's memorize our number bonds. And that practice comes in a lot of different ways. That the kids are touching, right? They're manipulating. They're taking 3 beans and they're putting 2 beans together and they're making 5 beans. Right? Now we have a group of 5 beans. Or they're starting with 5 beans and they're taking 3 out and how much are left. Or they are using a 10 frame. 10 frames are a really powerful tool for us. And really it's just 10 spaces as 5 and 5. Okay? So that if I have 2 here, how many do I need to get to 5? Right? So there's 3 spaces left. And if I have this, then how many do I need to get to 10? Right? And this 10, 10 is the number. It's like the absolute magic number. We use it all the time. And knowing how to get to 10, how to make and break 10, is one of the key pieces that they're working on. And they start that by understanding how do we make the numbers that get to 10, right? How do we make 5, right? And then we can double that to get to 10. And in first grade, they actually do a bit of some early multiplication, right? It comes as repeated addition, right? That 2 times 3 is the same as 2 plus 2 plus 2. But it's happening, and they're actually getting to see that multiplication sign. They're getting access to it really early, but it's because they're just now adding, right? They're adding on. And if we did 4 times 3, right? If we looked at that and said 4 plus 4 plus 4, the kids would say, okay, well, I know 4 and 4 is 8. But from 8 plus 4, I'm actually going to take that 4 and I'm going to break it up. And who said it? I heard it.
2.
Yeah, right? 2 and 2. Why? You make the 10. So you make the 10 first, and then you can add on. That 10 is super powerful. And so that becomes this like really lovely access point for addition and subtraction. For multiplication, even and division. Right? They were always making and breaking 10, and if we can find the 10, find it. Right? And I say it all the time. I mean, even upstairs, it's like that 10, that round number, it's really nice to work with. Make it easy on yourself. Right? And so, because we want the kids to be able to be out in the world and say, you know, that I do it with tips a lot. That's not going to come up for you necessarily, K2, but maybe it will. I don't know. You know, absolutely. But you know, if we have a bill, right, that's $23. I may just round that off to 20 and use the 20, right? Always coming back to numbers that work, that are easy to work with, because that at least gives you a solid grounding in what is this about, like how close are we? Are we close, right? And so the 10 really helps us, one, with the addition, subtraction, multiplication piece, but it also helps us in estimation and reasonableness, right? That if I can figure out what this is going to be around, then I will have a good sense of if the answer that I get then is reasonable, right? And because I know that I've solved problems, my answers were so far off, and I didn't actually have a clue that they were off. Like I didn't check for like, does that actually make sense? And this program really focuses on like, how do we check for reasonableness? Like, does this make sense? The kids are going to get a lot of opportunity to create understanding in their own way, right? How many people in this room need to touch things in order to really have it make sense for them? Anybody? Okay. How many people need to see it? Right. How many people need to hear it? How many need a combination of all of that? Right. So that's what's happening in the classroom. That the kids are being given this really great opportunity to do all of those things, so that everybody feels connected to it in their own way, right? So that if I say to you, let's model 7 plus 5, right? Some of you may take a piece of paper and draw it. Some of you may write it out as 7 plus 5 and break it into the number bonds. Some of you may see it in your head. Some of you may need to actually pick up cubes and start putting them together. And what's happening in the classroom is just that all of those materials are in front of them, and they're getting this opportunity to figure out what works for them, right? So I know the classrooms, I can speak to mine definitely, but there's always discs and things for them to touch, right? So that at any point, if they need to just take that out and start working with it, that they can. And it's encouraged. We want them to do that. We want them to figure out what works for them in terms of their own learning. And then when they don't need that tool anymore, they can move off of it. Right? So some kids in the room may be using discs. Some kids may not be. Some kids may be writing. And that's all okay, because we're all different people and we're all different learners. And we may get to a new skill and we go back to the discs, right? And we transition, and the kids transition as they need to. And that's encouraged, right? That they get to see what they need and use those tools as they need it. And so we're giving them experiences with different modalities, different tools, and then they get to figure out what works for them, right? So we're building these kids that know themselves as learners, which I didn't. Yeah.
Do you want to wait?
That's fine.
One thing I was surprised in first grade was that there were the timed problems that they do,
Mm-hmm.
because that to me sort of signals more of a traditional approach to math.
Sure.
Can you explain how that fits into Singapore?
Yeah, it's the fluency piece. So, yeah. So having access to all these ways of solving, right, and kind of building that, having those experiences, build your own understanding, and then also being able to do that quickly. So there's the two sides of it. Like, we have the learning piece of it, right, where we're getting to like play and use all these different tools. But at some point, this needs to be something that we just internally do quickly. And so that becomes this opportunity to try that out, right, in a really safe way, because it's not like there's no consequence for that, right? It's not, it just becomes this opportunity to get to know themselves in a different way, right? That some kids know it, but need the time to walk through it. That sometimes the time factor really impacts kids. Sometimes it amps them up. And it becomes like this really exciting, I can do this fast. And kids are working faster doing that than they are necessarily when they're working regularly. And so it's just, it's another tool that gives them and us more information, but also helps them to see the fluency of, I know this, I know 1 plus 2, I know 3 plus 3. And that is also a piece of what we want them to walk out with. Yeah.
Does that continue through the grade?
It does. Yeah. And it's just, they're a minute long. And yeah, we're doing it in 5th and 6th too. And some kids love them, some kids get a little stressed about it. Yeah.
So memorization is still important in math, because I know in 3rd grade, I don't know if we're talking about that, but they're asking us to actually do like multiplication flashcards.
Right. Because
So
sorry, I didn't mean
That
to.
just seems different than what the approach is here.
Yeah. So there continues to be experience with what is 3 times 6, right? And let's show that out, and let's write a word problem about it, and let's model it out. And getting access to that in these ways. And then at some point there's the transition of, well, we need to know these too. And so let's make sure that we've got it. And there's a lot of kids that are working on counting up, right? And so building that fact sense based on, okay, what's next? If we're doing 3 times 6, I might do 3 times 5, because 5s are nice and easy to work with, and then add 5 more and then 1, right? So that's gets to be a part of how do we get to those facts. Does that help? I saw a hand.
If I could just add, I have a fifth grader and a second grader, so I noticed that they still have to do traditional problems, and they still have to divide by decimal, they still have to do all that. But the Singapore math portion is really cool, because it was like, yes, I think this weekend summer had a portion where you had to estimate and then divide by the decimal. So you're looking at actually the real calculation, you have your math class, and then you still have a portion where you can estimate. So it's just, instead of just doing all division by the decimal, you also incorporate like logical stuff, like, okay, come on, what is 100 divided by, you're estimating. And I didn't have that as a kid. It was like just pure calculation.
Right.
Yeah.
Yeah, there is definitely the piece of how does this make sense to you? Like, how does this fit in the world, right? And can you take this outside of the classroom? Because if you can't, and what's the point, right? Like, what's the point? I mean, I know that like there is, kind of the expected course of instruction throughout K-12, right? But we're trying to educate kids. That's the point. We want them to know and understand this and be able to use it. They're not going to be in school for the rest of their lives. Yeah.
So just following up on the flashcards question, is that something that is part of the program, or is it that ideally they would get, by all the work you've been doing, they would just sort of get those facts and you just use that for if they actually need it, some kids that need it? Or?
It ends up being a supplement too, that we're creating the experience with it, with how do we understand that 3 times 6 is 18. And then now let's practice that, practice the quickness of it. It's more around speed than it is understanding. Yeah.
So what I'm looking for is what distinguishes Singapore, because clearly for me, grouping was present in my education. Grouping in 10, it's the decimal system. So I know this is working because my son is enjoying numbers, so I know that the method of getting the stuff into them is, so what I hear you saying is grouping. I hear you describing a tactile experience as well, and also a flexibility as opposed to rote memory. That's what I'm getting out of this, but I'm also seeing many, many, many parallels with what I remember my, let's call it a classical, or the decimal system, or because we group by tens. I mean, you go 1 plus 0 is a group of 10. So we were doing these same things. I'm just wondering, I'm asking for a little more distinction. Really, I don't quite see what the differences are in Singapore. I know they're noteworthy, but I'm not too sure if I can define them yet.
Well, math is math, right? So I don't think there is a giant difference, honestly. I think there's definitely a focus on mental math and really understanding numbers versus just rote memorization and computation. That algorithms aren't necessarily the way to go for every kid. And allowing the kids to build their own understanding versus me giving them that. Right? So, 1 second. Play with me, okay? How much is needed to get to 100 from 63? Tell me what you do. There's too many people talking at one time.
You count 7 gets you to 70.
What's your name?
Nicole.
So you said 63 plus 7. That gets you to 70. And then 70 plus
30.
30 gets you to 100. So how much do we need to get to, from 63 to 100?
37.
Great. Give me a different way.
My brain did it differently, and I thought it was interesting that I went to 60 plus 40 is 100, and then I subtracted 3.
Can you tell me your name?
Laura.
Laura. Thank you. So you said 60 plus 40 is 100,
Yeah.
and then took off the 3. Oh, no,
I subtracted 3 from the 40.
took off the 3
I
here.
got 37.
What else?
100 minus 63.
And can you? Yeah. I don't know how to spell your name.
Yeah, sure.
Can you spell it for me?
P-I-E-T-R-O.
P-R-E?
P-I-E.
P-I-E.
T-R-O.
T-R-O. Okay, but how did you do that mentally?
How do I do 100 minus 63?
Yeah.
37.
How do you get to the 37?
100, I mean, I just do the math.
Did anybody else do 100 minus 63? Mia, right? How did you do that?
I just did 100 minus 60 and then minus 3. Maybe I should do that.
100 minus 60, that's the 40, minus 3. Right.
I added 7 to the 3. Yeah, and so 100 minus 60 is 40, and then minus
100 minus, say it again?
100 minus 60. I'm sorry, I did 100 minus 70,
Oh, okay. 100 minus 70 is
and then
30.
3 plus 7 is 10.
Right?
So-
Anything else?
So where you're leading with this is that there are many ways, I think you're still on my question here, so
I am.
there are many ways that, and everybody solves the problem a different way. Let me ask you this then, because I get this, and the grouping is something that I really see is this thing, particularly with that set of blocks over there that I remember where something different was done. But, okay, so if you weren't using, and you make this maybe an unimportant question, because you're right, math is math. I'm not testing anything here, I'm just curious. But if you weren't applying, if the Singapore system were not in this room, and you ask that same question, how much is needed to get from 100 to 63?
Yeah.
How might we answer that if Singapore weren't in this room? Yeah, no, that's what I'm getting at.
This
Just
is what
'cause
I would do.
I want to see if I can. I
That's
think
what
it's
I
by
would do.
grouping.
And I would
if
take
remember from
this,
last year.
and I would do that. I wouldn't. I can tell you, as a third grader,
Right.
second grader, I could not have done that problem mentally. This is a second grade problem.
But the second
Right.
graders can do that now.
Yeah,
Yeah,
they can.
they can.
And they can teach me how to do that.
Right.
I mean, I think that, so with this, right?
Yeah.
We have a room full of people now who have created 5 different ways to get to the same place. And there are probably a couple others that aren't up here that just didn't get said. And what then becomes, what we can do with this then is that they're teaching each other, right? If you come into my classroom, I have these all over the place in my classroom because we do this.
Right.
And then what happens is that kids get to claim methods. That's why I asked you for your names, thank you.
Right.
Because then this becomes Nicole's way, right? And maybe I say to the next problem, from 72 to 100, and I say, try Nicole's way, right? Or try Laura's way, and see that, because maybe you didn't try that, and maybe you didn't even think about doing that, right? But now they have access and a connection, right? If it's my friend, and she's got this totally different way than I do, yeah, sure, I'll try it. Versus, this is not me saying, okay, here's what I'm going to do. I'm going to do 63 plus 7. I'm going to make the 10, and then I'm going to go to 100 from there. I'm not saying that. They're saying it. And they get to then be these experts. right? Where they're like claiming their knowledge. And I honestly can't think of like a more exciting thing for a kid than to have it be their way, right? And it's on the wall, and we're talking about it, and I'm referencing it, right? And you're now using it, right? And we're talking about that. And it gets to open the conversation too about efficiency, right? In 6th grade, we're doing double-digit by double-digit multiplication mentally, right? 65 times 32 mentally, right? And they're doing it in like 8 different ways. And that was my face the first time. I was like, this is not gonna happen. And they are, by the way, and it's amazing.
2008.
Yes. But here's the thing. We started with 13 times 19, and I had some kids say 13 plus 13 plus 13 plus 13 19 times. And I wrote that on the board. And some kids use that because it works for them. For me, I can't keep track of all that. I get lost. So it's not an efficient strategy for me. But it doesn't matter if it's an efficient strategy for me. If it is for him or her, that's okay. There's no judgment around it. And the more practice we get, maybe that becomes not an efficient strategy anymore when we're doing 63 times 95, right? I mean, but then we've spent however much time looking at everybody else's strategies, and we've now started to see, like, what else can we do besides just add? Yeah.
So I have great faith that come SAT time this is all going to work out.
Yeah.
You're going to be okay.
Yeah.
But for the lower grades, what seems to be the disconnect, and maybe this is what people were kind of asking about, you spend a lot of time touching and feeling and figuring it out, but then it comes down to they just have to know it in that time test. But there isn't a lot, it seems, of practice doing that time test. And I get that we don't have homework in K and 1 to reinforce that. But it's a challenge, I think, for some of the kids of why am I not finishing when I spent all this time coming up with this great way and we're doing it my way, but I still can't get to the end.
Sure.
So I think that's the hard part for us as parents is to watch, like, they may be able to solve the problems in different ways, but they still can't do it fast.
Okay.
And there's not a lot of practice doing it fast. It's just once or twice a day for those 60 seconds and it's over.
Right. So is it the timed factor or is it the practice factor? I
Well,
heard
think
two
those
different
two
things.
To me, those two are related, that they don't practice enough just doing it. So then when they get to the time test, not all of them can finish.
But isn't it the way that the teacher should be presenting it? Because, I mean, when my daughter was in 1st grade, that was the practice. So the time test is the practice, and the kids need to, I think it's the way the teacher can present it, that this is the practice. And so it's not finishing it the first time, and hopefully by the end of the year, they're getting more done.
1st grade, my son was coming home with 10 of those a week.
They seem to be doing them a lot less. I mean, I have
So
a
that
3rd
is
grader and a
practice.
1st grader, and they're not doing them nearly as much this year, and they're not.
No, I feel like I get 5 a day.
In 1st grade?
Yes, seriously, like it's insane.
And Miss Udell's class does more than food class, but
I would.
What I hear you saying is that the virtue is that if our children can't solve a problem, instead of trying to go back and go back to some system or formula they memorized, they can go through a process or test different processes that they may remember and resolve the problem again.
Yeah.
So they're actually doing the math as opposed to recalling just from memory.
Right.
Right.
And
because I watch that with my son. So I'll watch him enjoying himself and then describing what he's doing, and he'll have a similar problem next one, and the next one he'll do it a completely different way with different groupings and so forth.
Yeah.
And describe it.
And I think that different situations have different things that could possibly be more effective. Like this one, versus if I did, if I had like a 9s number, like 29 plus 32, I'm always going to go with the 10.
30 and 30.
Right. Because that's so close to 10. But with this one, nobody said it, but I thought of 63 plus 2, because I like 5s too. So 63 plus 2 is 65, and then maybe adding on 30 to get me close to 100, right? So that puts me at 95, but then I still need another 5 to get to 100. So I've added on all of these, right? But like, there are some, it's giving them the space to see, in this situation, what makes the most sense. And creating opportunities where we're talking about, okay, this one, maybe I use 5s, but this one I definitely am going to use a 10. And then, right, there's all this conversation about 21st century learners, right? That they have to be problem solvers, because they do, right? They need to be able to get into a situation and think about, what's the question that I need to ask myself, right? Where do I start? And I feel like, and I've seen, and I hear you saying you've seen this too with your child, like, we're giving them opportunity to just try, right? To see what makes sense and begin, and then go from there, right? Maybe you try something and get to the end and it doesn't make sense. Okay, fine. Start again, right? It becomes this building perseverance versus having to have the right answer. Like, it becomes this opportunity to just try it out.
So in first grade, are they giving them the opportunity to figure out different ways to solve the problem, so that, because I understand your question, like, kids are getting upset when they're not finishing the timed. So I get that they're trying in first grade to build the base, and they need to have some recall.
Yeah.
But before they do that, are they teaching them ways to get to that? Or are they just starting with the time test and kids are like freaking out because they can't get to the end?
So it's,
I was thinking, for me, it's the reverse. They spend loads of time figuring out and approaching it different ways, which is great. So I'm hoping come SAT time, they'll be good to go. But they can't then take this and translate it into the actual problem fast enough. And maybe in time it comes. Maybe by 5th or 6th grade it does.
it's a process for sure, but part of like the timed piece is just practice with that, right? It's practice of doing, and it's practice with timed, right? Because timed can be kind of scary, right? And you're talking about the SATs down the road, right? Which are timed, and there's constraints around that. So that there's the piece of the sprints and the pattern boxes help to give experience with that in a fairly low-key way, right? That it's like, okay, we're trying this, see how it goes. Yeah.
This is I'm getting is, to answer your question, is there's so much time spent on the 5 and the 10 that the 5 and the 10 become the uber building block, and almost the 5 and the 10 they get so comfortable with that that becomes what gets the efficient there. Because just take the 100 takeaways 3, we probably figured it out faster by doing all these things, getting to the 10, than if we did the old fashioned.
Right.
So I think that if you really focus on building that 10 building block, then efficiency should come.
Yeah.
Should come.
And we take out, how many times have you or the child around you the 9 doesn't become a 9, and that piece gets mixed up, and then there's no idea that that's wrong. And like this, I have to be able to justify and explain in my own head what's happening versus this where it's just like this process that I'm actually not connected to. And that's not to say that we don't teach this, because we do. But we teach it in conjunction with this, so that I may not have a kid in my class that's doing this subtraction. They're doing this. And that's okay too. Yeah.
It's one way of saying it.
Yeah.
To approach any problem and be able to break it down to a point where it's something you can memorize, you know instinctively.
Yeah, essentially.
Okay.
Right, you're going back to what you know.
4 is 10.
Right.
So get it to that point, and then you're done.
Yes. Yeah, if I can get to 10, awesome. How can I get to 10? What can I do? How can I get to 5? How can I get to something that I know to give me access to this problem that feels really big?
And is it also like, when you hear 8 plus 4, your brain gets you, that's the same as 10 plus 2.
Right, they do. I don't, but they do for sure.
I think sometimes with the lower grades, and I have this an issue for me, they're teaching all this in class, and then you see the time test. But what we don't see is sometimes the work they're doing in class, and also we don't have homework in first, or in barely any in second. We just have like one sheet at a week or something. So we don't get to see the practice. And I think maybe that's for the parents what we're missing.
That's really good information. I can definitely pass that along. Yeah.
They don't bring
Here's-
it home. They don't bring it home to do. We only see the finished product.
That is something I can
So it kind of
talk
seems
about.
like you don't know that you can't do it until it's too late.
I would, I am going to encourage you to start having the conversations with your kids about what they're doing. Like, and I don't mean that in terms of like ask your kids how they think through a problem, right? If you have on a sprint 7 plus 5, right, and they put 11, ask them, what did you do? And model what you might do. Say, oh, if I was doing that problem, I might do 7 plus 3 to make the 10 and then 2 more. And for some of us, that can be really uncomfortable. As kind of adults kind of removed, if that was not the way that your brain, that you were introduced to this or that you work. But have them start teaching you and talking to you about what is happening in their brain when they're doing problems like this. And start getting to know the type of thinker that they are. And share the type of thinker that you are. And talk about the fact that it could be different, that it's okay, you know? And like, have that be a part of your interactions with them. Even in the car, I know like carpool and you're sitting and you're waiting, and like if you have 3 kids in the car for carpool, throw out a problem and see what they do with it, right? Talk about the differences. And I know it's math, right? I do. And I get super geeked out about it, but I really would encourage, but that has come, I was not like the uber math person at all. I actually was really scared of math. So teaching it has become this really great opportunity to learn. And so I would encourage you to just be open to like having them be your teacher and having you be open to hearing what's new with them.
I'm just curious about second grade.
Second grade, yeah. I lost my, what's the clicker? Well, we've talked about a lot of it, honestly. Part whole is basically number bonds. That you have the whole, part, and part, right? Which, that to get the whole, we only need one of the, or we need both of the parts. But if we're missing one of the parts, we can get to it using the whole and the other part, right? And this is huge in terms of word problems. What information do we have, right? So if we have the whole, then I only need one part and I can find it. right? But I can subtract to find it. Or if I have both the parts, then I can add to get to the whole. So what they've done is 5 equals 3 plus 2. When we're getting into word problems, we've got the whole, and we're finding a part, we're subtracting, right? And it looks the same. But we're looking at the connections, right? How are these things connected to each other? Subtraction with we've done the mental math strategies. Yeah, right? Division, we talk about as sharing, right? In second grade, it's looked at as sharing. If I have 12 apples and there's 4 of us, how do we share this equally, right? And looking and actually doing that. In terms of we use place value discs. I don't know if you've seen them yet. They're discs, they're place value discs. So if I wanted to model this problem, I would say 2 10s and then 9 1s. Always using the 10 frame, right? Because the 10 frame, this says I only have 1 more to get to 10, right? So I have 29 plus 32, right? And so here, I'm looking and saying, okay, well, I only need 1 more to complete this 10, right? So I can take this and I can put it here. That completes the 10. And then I only have 1 more. This now becomes a 10. So how many 10s do I have? 1, 2, 3, 4, 5, 6 10s and 1 1. And we know 6 10 1 is 61 because we've talked about that in kindergarten, right? So, or first grade, in kindergarten and first grade. So we're using these pictures as a way just to reinforce what's happening. And the kids, these are on their desks and they're moving with them and they're making 10 and then they're putting that 10 ones in the bag and grabbing a 10, right? So now I have an extra 10 and I've got those ones are gone. And I'm seeing that trading and regrouping happening.
That's just for the concept.
Right.
That's not how they're calculating it.
No, right? But for the kids, as some of you already admitted yourselves, you know, they need to have that visual happening in their head. I was talking to a teacher yesterday, and she's super visual. And so when we were talking through this, she was drawing this out and writing that for herself because to have the language that goes along with what's happening is really important for her to see that visual. Some people, that they see it once, those discs, and then they don't need them, right? It depends on the kid and what works for them. But everybody gets this as a place to start, right? Those yeah, it's this constant like moving and manipulation.
Is it? Sorry. So when I sign up, I would just borrow the 1. Like in my head, I'm borrowing that 1 and put it over. I'm making the 30, then I'm remembering, right? So would that apply to what she's saying, where doing it this way is taking longer to get, and therefore that becomes a speed bump? I'm only theorizing here.
No, yeah.
You see what I'm saying? Like,
I do.
Know, is that as everything switches in later, but this is a great basis? So I love math and I got lucky, but my sister hated it. So she would have had this method, maybe she got too low in it.
Right, so I'm going to answer your question and somebody's who I heard over here happening at the same time, which was how do we then translate this to 29 plus 32, right? Because we need to be able to do that. And so this is happening. We start here, right? We're working with this. And then there's a transition point kind of midway where now we're modeling this and at the same time I'm talking about this. So we said we needed one of the 1s to make the 10, right? But we had 1 extra. So I have 1 1 now, but I have an extra 10. So what do I have to do with it? I have to put it here because it's a 10 now, it's not 1s. So now I've got 1 extra 10, and that's here. How many 10s do I have? Well, I had 2. I have one extra, that's the 3, and I have the 3 from the 30. So now I have 6 ones. I have 6 tens, 1, right? So there is this starting here, progression, right? I move now to both, and then at some point, I'm going to transition to, and say try it. If you need the discs, use them. If you don't, cool. It's okay. And that becomes an opportunity for the kids to see where they are. Do they need the discs? If they do, they can use them. They have access to them. But if they don't, that's okay too.
At what grade do you start introducing the more traditional way of doing this? They've learned in Singapore that there are lots of ways to get to the answer, and there's not a right or wrong way, because we all do differently, and I think that's wonderful. But then at what point do they go to the traditional, and why do you go to that at all?
So addition and subtraction with regrouping comes in 2nd grade. They're getting all of this at 2nd grade. So they're getting the modeling, they're getting the mental math, and they're getting the algorithm all at 2nd grade. And then they get to choose, right? But I'm not saying in 5th grade that you have to use one or the other.
You're not? Okay. It's whatever works for them.
Yeah.
And so outside of, say, public school or private school setting, if they're not using Singapore, then it's more that they're mandated that this is the way you have to do it, and you have to show me the steps of how you do it?
That's definitely where
That's
I
what
came from. Yeah.
I don't know if that's still
Yeah.
stands.
That is my understanding.
Okay.
I haven't taught in public school in Los
Okay.
Angeles.
I look at the number bonds, and I think the whole point of that ultimately is for that to become instinctual memories. You're not going to give them number bonds of 106, 8, 2, and 3, 4, but the ones you're giving them are so that every time they see a 5, it's 2 and 3, like that.
But I might do something like, even like 13 plus 9, right? And I don't expect them to have to know that like automatically, but what I do want them to know is that this could be 12 and 1, or, and then go this way, or I could do 13 plus 9, and this could be 7 and 2, and they can go this way, right? Whatever bonds that they're comfortable with, right, are what they're going to then use.
One more question on the timing.
Sure.
Is it to get them used to being timed, or getting them to have those facts just become rote, or is it a combination of the two?
It's definitely a combination. So it's 9:30, and we've done a lot. I'm happy to continue talking for a few minutes, but I totally understand if this is time for you to go. So thank you for being here. Have a fabulous day. Yeah. I saw it.